see whether screen sharing works as desired. Can you see my screen?
We can.
Okay, cool. So yeah, I wanted to give an update to this group on the effort of renovating VolksForth, which I've been sort of doing on the background thread in the last year, very little, for at least 2 years or so. Incidentally, a metacompiled forth. So I've used the metacompiler or target compiler, as the VolksForth people call it, extensively, but I haven't dug into it enough to understand it. That's one future project yet. So this is a short overview. What got me to it, I need to make a hard tip to Martin Fowler, because what I'm doing here is mostly really one big refactoring. Funny analysis of the sequence of the steps for each platform, because VolksForth is essentially 4 platforms all forked one of another. And yeah, the eventual plan of merging the forks and future plans. What got me into this is I was writing this C compiler in Forth, and I wanted, in the 90s, on the Commodore 64, and I wanted a better Forth core for it, smaller, and at some point when I migrated to emulator, I wanted to be able to use stream sources, which VolksForth couldn't do. And yeah, obviously, as small a kernel as possible. And the other motivation came from Carsten Strothmann, the other maintainer of VolksForth, who would like the whole thing to move into the direction of ANS. And so the planned way to achieve this was first to implement stream handling, make the block words optional to get them out, do that for all platforms, and then eventually merge the codes from the different platforms into a common code, so that in the end, when you move things towards ANS, then you just have to do it once and not 4 times. One thing I really wanted was safety nets for the changes I was doing in the Fowler refactoring way. The haze tester, of course, is useful there. And then I had this ANS test suite, but VolksForth is Forth 83. So what I found, what worked, was to build a hacky little shim, and it's roughly 100 lines, that adapts most, or you could call it, adapts VolksForth to ANS, or the tester to VolksForth, doesn't really matter. I had to comment out something like, I don't know, 1/5 or so, because some features just aren't there. But what I in the end had was that I could use the existing test as a regression test suite using the core, core plus, core extended, double, and block test sets. And then I would, just for the sake of automation, because I really want all the build and test steps automated, diff all the outputs, all the log outputs against golden files. I ended up using GNU-make to drive the whole builds. Advantage is the rules that you can make with make are pretty powerful, and some of the things I ended up doing seem to be a little bit hacky. the price you pay is the well-known cryptic syntax of Make, especially of GNU Make. So for a while, I've been consulting that man page on a very, very regular basis. Then I needed emulators for the Commodore machines. That's the relatively obvious choice is Vice. X16 EMU, I'll talk about it in a short detour, is an emulator for a new retro computer based on the 6502 called Commander X16. For DOS, the old DOS box, run CPM for CPM, which I have in the works right now. Atari will be the one for Atari ST. And what really turned out to be a bit tricky was to make the emulators scriptable in the sense that I could drive them fully automated and well, they're not really headless, but fully automated from Make. How to get keystrokes in the end into the emulator, input into the emulator, and how to terminate the emulators. Not all of them are designed for doing that from the inside, but you need to do that. The trick I ended up with is to define a certain file that the emulator, that the guest deletes, signaling to the host, okay, I'm done, you can terminate me. And that ended up working pretty nicely. In the case of run CPM, I actually had to extend the emulator a bit. Another fun side aspect is the different character encodings that you're dealing with. So the Commodore machines have their own PETSCII, which you need to convert to and from. I'm writing all the source codes now in Linux in a regular editor. And at least the line endings for DOS and for CPM also need to be adapted. And yeah, and then another bit was to define actual target compile rules, again with log file, full log file compared, just to verify, because that isn't an emulator run target compiler won't easily tell your Make outside whether it had or had not encountered a compile error. So a lot relying on guest-written log files there. Then there were a few sort of odd boundary conditions, I call them, which in the end determined the procedures or the steps of sequence per platform. So I wanted as much testing as early as possible. All the tests I had were stream sources. The stream include that I implemented, or the first one that I got to work and that essentially I stuck with, uses the text input buffer, which is 80 characters by default in VolksForth. Unfortunately, some of the tests are longer than that. And yeah, automatic verification I've already mentioned. And this is what, for each platform, the actual renovation from block source. I think I didn't mention that. Traditionally, VolksForth is a block source oriented forth. The target compiler reads from block sources. And what I wanted in the end was a forth that I can easily change. So eventually the sources needed to be moved to stream sources. So first get a hello world and then in an emulator to work, get log file output so that you can verify something, implement for each individual target an include with a simple test. And then the first tests can be can be run, the preliminary and the core. And once that is done, that is basically the safety net that any automatically new generated Forth kernels from the target compiler are actually working. The target compile rules were the next, running the tests, of course. And then slowly I could migrate the block kernel sources to stream sources. Initially in just one big file, splitting it up into smaller files came a bit later. And as it turned out, the best way to make that migration in the actual compile was from the inside out, from the outside in. So the first thing that I changed was was the load screen. So I'd have a screen source load screen that then loads block sources, and then slowly more and more code got migrated to stream sources. And once I had a fully stream implemented and stream source compiled, target compiled Forth, then I could change the length of the text input buffer. I didn't want to do that first because editing, at least in the coding environment that I have, editing block sources I find quite cumbersome, so I try to minimize that. So once that is enhanced, I could run the remaining tests, then integrate the include into the actual kernel, so that it doesn't have to be compiled on top of the basic kernel. And then came the final step of extracting the block words into a separately compilable file, so that you could have a smaller kernel without block words and a larger one with. And this sequence actually is, so the first time that I established that was on the first platform that I did, my home ground Commodore machines. And the sequence then proved, especially now getting back to it after a bit of a break, as a really useful recipe to go back to. Okay, this is like a checklist. This is how I go for each platform. And that has worked really, really nicely. The ANSI shim stems from even the first platform. Didn't much change, I think. Yeah, it was about 10% of the little less than 10% of the test code that I had to comment out. I think I've already touched on the terminating trick with the emulator. And one interesting detail on the Commodore machines, so C64, C16 with 64K, also essentially equivalent to the +4, and then later also the Commander X16. I ended up using the C64 emulator for all the builds, because it turns out that the emulator, the C64 Vice, was just hands down the fastest of all of them. Yeah, quick detour about the X16. That was something that more or less fell out of the this whole renovation effort. It's a machine built by a YouTuber, Dave. Damn, should have written down the name.
Murray. Dave Murray.
Dave Murray. Yeah, right. And because it's very similar to the Commodore machines in many ways, it was actually pretty easy port. It doesn't have block words because there's no the current DOS implementation on that machine doesn't really lend itself to direct block access. And what came out of it is that my C compiler was, to my knowledge, the first self-hosted C compiler on that machine. In MS-DOS, turned out that DOSBox was the most suitable emulator, though it's a little bit slower than NU2, I think. But the level of compatibility was a little bit higher. Didn't have to hack anything there. The emulator can exit itself if you pass. No, you can just interactively exit it, and you can easily pass a number of commands that it shall run from the outside. One hack I had to go for is, because there already was an include for block sources, I decided to leave that in place and make it kind of file type smart. If in the first, I think it's 100 or 200 bytes or so, it doesn't encounter any new lines, then it will continue to include the file as a block source. Otherwise, it will go ahead and read it as stream source. One thing that I found here was that maybe because this is the last platform in the forking sequence, I had to do a little bit more reshuffling of the code to get the block sources out of the kernel. The one that I'm hacking away at the moment is CPM. So I learned myself some very old file IO. And overall, it's in terms of development environment, it's a pretty friendly thing. The emulator is much faster than any of the other ones that I had. And I'm currently at the point where the preliminary and the core tests are running, but in a little bit hacky way. The one thing I haven't figured out yet is why the stream include, my stream include doesn't nest. So that's what I'm debugging right now. And then the next step will be setting up the target compile. Then the fourth platform in line will be Atari ST. Will be the first time that I'm doing anything with that machine, even if just in emulator form. The nice thing is that the Atari emulator has a really good reputation for being scriptable. Plus, Carsten, I think, knows the author. So Carsten Strothmann of the German Forth Gesellschaft. And then the step after that, looking forward to already, will then be to start to extract common streaks of code from the four platforms into a common directory. What I'm not yet quite clear about is how I'll handle the probably different collisions of code and non-code words on the different platforms. So something will be in code on one machine and in Forth on the other, and you would like to keep the fourth word in the common directory. I haven't quite figured that out yet. The ideas that I have is either this kind of if and def syntax, or maybe a present smart colon definition that will just skip to the next semicolon if a word is already existing. And then one further idea that we in this case being Uli Hoffmann and Klaus, name failure here again.
Schleisig?
Yeah, Klaus Schleisig, thank you. And Carsten as well, is a Linux VolksForth. It will still be 16-bit, but just to be able to run this kind of nice, simple, and the idea stems from Klaus to use as an educational tool. I'll be happy to have a Linux platform for any target compiles, so that those don't have to run in the emulators again. But that hasn't progressed further yet than just to figure out how to write an ELF binary, and we've heard some about that today already. And I think that's all I have for today. Thank you.
Thank you, Philip. If anybody has any quick questions, we'll accept them now. Otherwise, we sort of need to move on. So, questions?
One question. Have you thought about a series of parallel namespaces?
For the code and non-code words?
As part of the metacode process to discriminate between code on the platform that, like GForth or whatever platform you're actually, generating the metacode from, and the target platform.
Yes, I think the target compiler uses vocabularies, and I forgot to mention they're all self-hosted. So as yet the target compiles or the meta compiles all happen on the emulator for the own system. So the Commodore ones are meta compiled on the C64 emulator. The DOS one is meta compiled on MS-DOS, on DOSBox, etc. But yes, the meta compiler or the target compiler, I think, makes heavy use of vocabularies. But my knowledge there is not very deep yet.
Well, one other thing that I've seen done was I've been using the 8th compiler, and
okay.
He uses a namespace prefix, so like a very small, like 2-character or 3-character prefix with a colon to keep words in their own namespaces and discriminate them.
Interesting. Okay.
All right. Thank